Hi guys, how's it going? Okay, so we are taking a brief interlude from Trig to go over theoretical probability. Um, and well, this is video one, and you better be being nice to Mrs. Barry, and you better be listening to this and not just taking notes. Okay, so probability is the measure of how likely an event is to occur. So think about it as like, how likely are you to win the lottery if you buy a ticket? How likely are you to get hit by lightning if there's a storm going on? All of that sort of things. So the set of all possible outcomes is called the sample space. Okay, so sample space, right? For likely outcomes, the theoretical probability of an event is known as P of E. Um, and it is the ratio, so think fractions, of the number of favorable outcomes, what you want, when you think of favorable outcomes, think of what you want to the total number of outcomes, right? So you want to be the person who wins the $30 gift card, right? There's a class full of 40 kids, so you would be 1 out of 40. Okay, so let's apply it to some problems here. I'm going to do a few, and then you are going to do a few. Okay, so a jar contains 32 red marbles and 28 blue marbles. What is the probability that a randomly selected marble is red? So what you want to do is you want to think of, okay, I want a red marble, so 32 is going to go on top, and your total number of marbles, so we are going to add 32 and 28 and get 60. All right, well, you always want to reduce if possible. These both are divisible by 4, so I will get 8 over 15. That's the likelihood of me getting a red marble out of a bag of 60 marbles. Okay, a letter in the word restoration is randomly selected. Actually, you guys are going to do that one on your own. I'm going to jump down to number 3. What is the probability of drawing a heart or a club from a standard deck of cards? Okay, the reason I want to do this one is because you guys might not know the number of cards in a deck. There's 60. What? Sorry, there's not 60. I'm like, wait, what? I was looking over at my notes and I looked at the wrong spot. There's 52 cards in a deck. All right, and of those 52, there is 13 of each suit, so there would be 13 hearts and 13 clubs. So you would have a total of 26 from those, 26 out of 52. All right. You would reduce that down to 1/2. So you have about a 50% chance of drawing a heart or a club. And just in case you're wondering where I'm getting those numbers, remember that this is the total number of hearts and clubs of hearts and clubs. And this is the total number of cards in a deck. Some of you know that, some of you might not know it, but that's kind of why I wanted to go over them. For anything that you don't know while we're doing this and I'm not here, go ahead and do an internet search. All right, like deck cards in a deck. What are vowels? What is a prime number? Those types of things. Use your resources, guys. So a bowl of fruit contains 3 apples, 4 oranges, and 6 bananas. If a piece of fruit is randomly selected, man, I should have painted my nails. What is the probability of selecting an orange? Okay, so you want to figure out the total amount of fruit And if we add 3 and 4 and 6, we're going to get 13 total pieces of fruit. And we look up here and we see that there are 4 oranges. So 4 out of 13 would be the likelihood of you selecting an orange. Okay, so you guys are responsible for doing number 2, number 4, and number 6, right? Your notes need to be completely filled out. So we are going to move down here to complement of an event. And complement just seems a little deceiving because compliment, you think it's going to be all good things, right? We all like getting a compliment. The complement of an event, though, it's the probability of an event not happening. So probability of an event not happening. Okay. Since the sum of all probability in a sample space is equal to 1, all right, remember, think 100%, right? Or 1. The probability of an event not happening is P not E, or 1 minus the probability of the actual event, which sounds confusing, but I'm hoping it'll make more sense as we do some problems. Okay, so the probability that it will snow tomorrow is 7/20, or 7 out of 20. What is the probability that it will not snow? Okay, so you want to think of the probability of an event not happening. So 1, right, our total possibility, minus 7 out of 20. Okay, well, don't forget you can use a calculator, but also if we're thinking of 1 and we know that it's out of 20, it might be easier to do 20 out of 20. And I got this 20 out of 20 from the 20 down here. And from there, we can subtract 7 minus 20, or 7 out of 20, and we will get the likelihood of the event not happening, which is 13 out of 20. That would be our answer. You can subtract it from 1, so 1 and subtract the likelihood of it happening. Or you can just think of it as, okay, what's my original denominator? 20, okay, 20 out of 20, and then minus the probability of the event. Okay, the other one I want to do is the spinner to the left. Well, the spinner to the left is missing. Where'd it go? It's a typo. But the spinner to the left, and I'm not going to do it justice because well, you know how my drawing skills are. Okay, the spinner to the left is from the number 1 to 16. Find the probability that it lands on a number that is not prime. Okay, well, the prime numbers, 1 through 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16, we would do, there's 16 total numbers, so 16 over 16 minus 10 over 16, which is going to give you 6 over 16. That reduces, they're both divisible by 2, so I'm going to get 3 over 8. All right, so the probability that it is not prime. Okay, so you want to think of, there's 6 numbers here that that are, not going to be prime. All right, and then that reduces. Oh, goodness. Wow, sorry, guys. Okay, I want you guys to try to do number 8 by yourselves. And 2 dice are rolled. What is the probability of not getting doubles? All right, so I'm going to do 10 with you. We're going to think of it. You can think of it as 1 minus, or you can think of it as, well, there's 6 sides on a dice, right? And there's 2 dice, so there's 36 possibilities. All right, so 6-sided dice. And 2 dice. All right, so 36 possibilities. So you can think of it as 36 over 36 if you'd rather. And of not getting doubles, well, you could get a 1 and a 1. You could get a 2 and a 2, a 3 and a 3. So there's 6 possible sets of doubles. So you could think of that as 1 minus 6 over 36, or 36 over 36, which is 1, minus the same thing, 6 over 36. Either way, for both of these, you're going to get 30 over 36, and you're going to reduce that to 5 over 6. Okay, so again, you guys are responsible for doing number 8, and hopefully my jarbled explanation of this makes some sense. Complement of an event. Okay, let's flip our papers over. We are going to talk about compound events, and this stuff is kind of fun. All right, so we have independent events. When the outcome of one event does not affect the outcome of another event. Okay, so that means you want to think of it as something being replaced. Okay, so you're grabbing marbles out of a bag. Before you reach in and grab another one, you put the one you originally grabbed back. All right, so think of being replaced if it's an independent event. If it's a dependent event, think not replaced. All right, so you grab from that same marble bag, but this time you didn't put it back before you reached in. Okay, so what this looks like for an independent event when you replace them is the probability of A times the probability of B. Okay, so you're going to take those probabilities and multiply them together. All right, for this one, it's going to be the probability of A for dependent events times the probability of B after A occurred. Okay, so probability of grabbing a red marble. All right, you didn't put it back. So it's going to be a lesser number this next time. Okay, so the first ones that we're going to do up here are all independent events. We're putting it back, all right? So a dice is rolled 3 times. What is the probability of getting a 1 on each roll? Okay, well, the first time you roll a dice, there's a 1 in 6 chance that you're going to roll a 1, right? Nothing affects it. So on the second roll, there's still a 1 in 6 chance, right, of rolling a 1. And again, a 1 in 6 chance of rolling a 1. All right, that becomes 1 out of 216 rolls that you can roll a 1 on a dice. Over here, a coin is tossed, then a day of the week is selected. What is the probability of getting a tails, then a day starting with the letter T? Okay, well, the probability of getting tails is 1 out of 2. There's 2 sides on a dice, heads and tails. So the probability of you getting tails is 1 out of the 2 sides. And then times picking a letter that starts with T. Well, there's a day of the week that starts with the letter T. There's 7 days in a week, and there's 2 days that start with the letter T. All right, which becomes 2 over 14. Well, that can reduce to 1 over 7. There's a 1 in 7 chance that you will get tails and then pick a day of the week with the letter T. Okay, so up here, a bag contains 8 red crayons, 14 purple crayons, 6 yellow crayons, and 4 green crayons. This is independent, so that means we're replacing it, right? And then you're selecting your next pick. Okay, first thing we want to think of is how many crayons are there total? So we're going to add 8, 14, 6, and 4. We're going to get 32 total crayons. I don't know about you guys, but don't Volkswagens smell like crayons once the new car smell wears off? I always thought that Volkswagens, like Jettas growing up, smelled like crayons. Anyhow, okay. So the probability that we're going to pick a purple, then a yellow. Well, out of the 32 crayons, there's 14 purples times the 6 out of 32 because we put it back, right? Crayons. So we are going to multiply 14 times 6, and you will get 84. And 32 times 32, and you will get 1,024. Okay, well, that reduces down, which you can do in your calculator, to 21 over 256. Hooray! Not too bad, right? So let's look here. Let's do 2 purples. Okay, so remember that there was 14 purples out of 32. You put it back, so even if you did get a purple, there's going to be 14 again, and there's still going to be 32 crayons because you put them back. Well, 14 times 14 is 196. 32 times 32 is 1024. And that can be reduced to 49 over 256. All right. Okay, so that's independent, right? And you're thinking replaced. All right, or put back. We're going to move down to dependent events, and this time they are not replaced, okay? Dependent events. So we're still talking about the same 32 crayons. But we're not putting them back this time. So the probability that we pick a yellow, well, there was 6 yellows, and when we originally pick, there's 32 crayons. Okay, well, we're not putting one back this time, so it's going to be 31 crayons. And then we're assuming that we grabbed a grabbed a yellow, so we're going to look to the total amount of reds, and there was 8 reds. So we're going to multiply across, and 6 times 8 is 48. 32 times 31 is 992. All right, and we're going to reduce and get 3 out of 62. Okay, So now we're going to look at the likelihood of getting 2 greens. So how many greens are there? If we look back up, we see that there's 4 greens. So 4 out of 32. And we're hoping that we got a green on our first draw. So that means there'd only be 3 greens left. And of course, 31 crayons. So 4 times 3 is 12. 32 times 31 is 992. That can reduce down to 3 out of 248. Not the best odds, but not the worst. Okay, so last one I'm going to help you with. And remember, all of these need to be done in order to get credit, at least attempted. A card is drawn from a standard deck. Okay, remember, 52 cards in a deck. It's not replaced, right? We don't put it back, and another is drawn. What is the probability of choosing a heart then a spade? Well, there's 12 of each suit. So a heart, there would be 12 out of 52 times a spade. Well, we're assuming we got a heart on the first time, so there's still 12 spades. However, there's only 51 cards. Oh, goodness, guys, I'm so sorry. There's 13 of each, not 12. 13. 13 of each. Hopefully you catch my error before I did. Okay, so 13 times 13 is 169, and 52 times 51 is 2,652. And that will reduce down to 13 over 204. Okay, so you guys are going to finish this problem. Miss Berry is going to give you your vocab sheet that you need to have filled out. And I am going to link a Quizlet to Canvas. And you guys are going to do that. And then you also have your homework, all of them that need to be done. I hope you guys are having a good day, and I will see you soon. Bye.